All right, folks, how we doing? This is Mr. Emmons going over, I guess, how to factor out GCF, greatest common factor, identifying greatest common factor, factoring it out. So I find it helpful to maybe talk about prime factorization. I know we did a little bit of this in class. Prime factorization can be helpful if we are struggling to find the GCF. Some of us will be able to just look at the terms and identify it. Others may need prime factorization. If nothing else, I do think prime factorization is worth reviewing from time to time as it can be applicable in different areas. So 60, maybe that breaks down to 3 times 20. 3 is just 1 times 3. We're going to rewrite it anyway. And then 20 is 4 times 5, making the prime factorization, whoops, not done yet because 4 breaks down 2 times 2, making the prime factorization of 60 2 times 2 times 3 times 5. All right, something like 18 times x, when we get there, I'm going to say we work with the 18 the same way. That's 2 times 9. 2 is 1 times 2. Just bring it down anyway. 9 is 3 times 3. What do we do with the x? Well, just bring it down. So the prime factorization is 2 times 3 times 3 times x. And looking at 12x squared, again, 12, same way. 2 times 6, 2, 2 times 3. And then the x, we're going to break that down into, sorry, the x squared, x times x, making the prime factorization 2 times 2 times 3 times x times x. And so now in part 2, if I'm looking to find the greatest common factor of 18x and 60, I can say 18x was equal to 2 times 3 times 3 times x, and the 60 was equal to 2 times 2 times 3 times 5, and the greatest common factor will be what they have in common. So I'm able to see that they each have a factor of 2, and they each have a factor of 3, making the GCF 6. All right, and similarly, 12x squared and 18x. Let's see, 12x squared we said was 2 times 2 times 3 times x, and 18 times x was 2 times, I'm going to line them up, try to. So when I try to identify the GCF then, sorry, keep scrolling, they have a 2 in common, they have a 3 in common, and they have an x in common, making my GCF 2 times 3 is 6x. All right, so then when we get into something like this group, where we want to first identify the GCF and then factor, if we need to, we can use these skills, prime factorization and identifying the common prime factors, to then get the overall greatest common factor. Some of us, though, will be able to just look at the two terms, 4x squared and negative 3x, and identify the GCF as a 1x or just x. But that's just the first part of the problem. And the way I'm asking you to factor out the GCF, or factor by using the GCF, what I'd like you to do is take the entire initial expression. We're going to multiply by the greatest common factor, and we're going to divide by the greatest common factor. All right, and in the previous lesson, we spoke about how to do this division. We said it's actually the terms written separately, they are each divided by x. And so our final answer, 4x squared divided by x, 4 divided by 1 is just 4. These variables, we can subtract the exponents and then subtract. X divided by x is just 1. And so the GCF is x. If we divide everything by that x, we get 4x minus 3. So that's our final answer. We factor out the greatest common factor. We identified it, then we both multiplied and divided by it, and that's our final answer. In B, same deal. When there's a trinomial, we're first looking to find the greatest common factor at this point. Between 10, 20, and 5, I believe the greatest common factor there is a 5. Now, between y cubed, y squared, and y, we're going to come up with a single y. In the second part, once again, we're going to take that entire expression, 10y cubed plus 20y squared minus 5y, the entire expression. Let's multiply by the 5y you identified as the GCF, but then also divide each one of those terms by the same 5y, making our final answer, all right, 10 divided by 5, is 2. Y cubed divided by y will give me y squared. A positive divided by a positive, 20 divided by 5, y squared divided by y. A negative divided by a positive, 5 divided by 5 is 1. Y divided by y is also 1. So we're just looking at overall a 1. Final answer, 5y times the quantity, 2y squared plus 4y minus 1. When we're ready to factor out a common binomial, you should be looking at a common binomial. Okay, common. What do they share? So in this case, the actual binomial x minus 3 is technically the GCF. So really what we're going to do is the same thing. We're going to take that entire expression and multiply by x minus 3 while also dividing by x minus 3. So we'll have the x minus 3 out in front. 7 times the quantity x minus 3, then divided by x minus 3 is just going to be 7. And then negative 2x times the quantity x minus 3 divided by x minus 3 will just be negative 2x. All right, I'll do B really quickly just to show you that it is important to understand that there is a 1 in front here. I mean, I can explain it a different way as well, but essentially we're going to, like I said, take the common binomial. We'll take the entire expression. All right, we want to both multiply by that t squared plus 4 and divide by that t squared plus 4. When we do that, we'll get t squared plus 4 out in front and do this division. T squared plus 4 reduces with t squared plus 4. I just have a negative t. And now here, if we say it a different way, t squared plus 4 divided by t squared plus 4 is 1. So we get plus 1. All right, it's not nothing, it's 1. Anything divided by itself is just 1. So this is our final answer, t squared plus 4. That common binomial is just right there, factored out, and what remains is a negative t plus 1 after we do that division. And really quickly, I trust you can do C on your own. D, if that binomial is not shared, is not common, we're just going to say that it is not factorable. All right, the last set, and that's really important that the binomial is important. We'll see that in this last set of problems. This last set of problems, it's essentially 3 problems in one. There are 3 steps. I first need to find the GCF here. So between 12 and 9, I think we're looking at a 3. And between a cubed and a squared, the GCF would be a squared. Okay, and I'm factoring that out. I'll have 3a squared. Do the division. 12 divided by 3 is 4. A cubed divided by a squared is a. Negative 9a squared, do the division. Negative 9 divided by 3, negative 3, a squared divided by a squared, well, that's just 1. 3 times 1 is 3. That's one step. As a second step in this second group, I need to find the GCF between 20a and negative 15. That'll be a 5. Do the division. 20 divided by 5 is 4. A divided by, well, I guess I'm dividing by 1, so it's A. And now negative 15 divided by 5 is negative 3. Sorry, getting ahead of myself here. It was a positive 5, and then 4A minus 3. Is it going to get, okay. And now, really important, this is the third step. I do have a common binomial. If I don't get a common binomial, I did something wrong. I would go back and check my work. So please make sure you do get that same binomial, in this case 4a minus 3, to show up in each of the two groups. Once I have identified that common binomial, I can write it. And if I do that division, if I divide this first half by 4a minus 3, it would just be 3a squared. And if I divide this second half by 4a minus 3, it's just plus 5. And that's my final answer. 4a minus 3 times the quantity, 3a squared plus 5. You'll finish these problems. And we have homework 3 of each type, identifying the GCF, factoring out that GCF, factoring out the common binomial, and then factoring by grouping. That's it. Thanks for watching.